Hello everybody to part 2 of the Einstein platform services series we're doing. Last time we had a look how we can let the pre-trained food classifier label food images. Today we will have a look in another aspect of the Einstein vision services. More specifically, today we will have a look at the OCR possibilities within the Einstein Vision APIs. Now, what does OCR stand for? OCR stands for Optimal Character Recognition, or in other words, reading text from an image. Like if you would Google OCR, and that's what we're seeing right here. So we see the images, and the computer will try to detect whether there is text on the image, and if there's any text, it will indicate where it finds it. So like previously, the labels this time actually will be words, sentences, but on top of that, we are not classifying an image. We are doing some type of object detection where the object in this case are characters. So Einstein will provide you in the response body the actual coordinates of the bounding boxes. Now the bounding boxes are these rectangulars which you can see on the image, and it's very typical for OCR analysis. Alright, so those of you who have been working with Tableau Desktop for a longer while probably know that there is this PDF connector. This PDF connector allows you to connect to PDF files as long as there is some type of table structure to be recognized in the image. Now, there are some limitations to this connector, and it works very well to scan these very standardized documents. Tableau will be capable of getting the data out of there for you. Now, the problem arises, and as an example, I've taken here this receipt, which I Googled. It was my first hit. It's a receipt from Walton Stores. Now, there's a few things about it. The first thing you need to notice is, and you will notice, receipts are kind of structured to the extent that the product name and the prices are next to each other. We see the name of Walton Stores on top, and we have our total at the bottom. Now, besides that, we also see that if you buy courgettes, for example, we have the price per kilo. So you have the price per kilo and then the price you actually paid. Now, the problem with this is that although it has some characteristics of a table, Tableau will not be able to read this image. Let me give you an example. So if we go to Tableau and we select PDF file connector, where is the... I'm going to the actual PDF of the receipt and I click open and I click OK. You see, this is the error you will bump into. The page or range you specified doesn't exist or contain any tables. End of story? Not exactly. The challenge of today is that I will try to create a receipt scanner making use of the OCR models that come with the Tableau Einstein services. Now, instead of first connecting to it directly in Tableau Desktop to the image, we will make use of Tableau Prep. Okay, so the first thing I have done, like previously in part 1, I am storing my images of my receipts on a Google Drive location. So imagine you have a drive where you want all your receipts to be stored. Do notice, this is just a minimal viable product. It's a test case, whether we could make something. Like ideally, you would make an image with your iPhone, the image would automatically be stored somewhere and then be picked up in the data flow process later on. For now, I am storing my receipts, more specifically my Walton Store receipt, in a Google Drive. For this exercise, I have uploaded my receipts using a Google form. so that all the images, as you can see, nicely get stored with the respective link on Google Drive in the table. This will allow us to connect to them very easily from Tableau Prep, just like we did last time. All right, here we go. So first of all, we connect to our table which contains the URLs of the actual receipts. Then, secondly, and I'm not going to deep dive into the aspect of how to prepare the URLs because I talked about it in part 1. If you want to know how to feed the URLs which contain the image of the receipts to the algorithm, feel free to check part 1. Now let's have a look what our data looks like. It's very straightforward because the only thing we do is connecting to that little table on our Google Drive. So there isn't much to it. As you can see, it has a timestamp when I uploaded the receipt. Secondly, the one who uploaded it, obviously that was me. Then I created a calculated field to parse the key of the image out of the URL. And then I created a field in the next step, which I will feed to the algorithm. Before we go to the actual Python script, which performs the OCR tasks, let's have a look at the possibilities we have. So we are within the Einstein Vision APIs, and this time we will make use of the OCR optimal character recognition. So here they write, use OCR models to detect alphanumeric text in an image. That is what we are going to do. One little nuance here is that we have the possibility to use two types of models. We have the OCR model and the Tabulate v2. I'm not going to use this one because I think this one looks and will behave mostly like the PDF connector, which we already know in Tableau Desktop. So as it will create tables, it probably will assume to have some borders which give an indication of the rows and the columns. So I don't want that. I want my image, I basically want any image just to be able to be fed to the algorithm. So as you can see here, they indicate themselves that this is ideal for easily scanning business cards or images that contain unformatted data. In this specific context, I will assume that my receipt is some kind of unformatted data. And as we will see later on in the Python code, we also want to specify what kind of task it needs to perform. Here we are once again in the Python script we are using to perform the actual OCR task. So just like previously, we are importing requests to perform the post requests. We are importing pandas just as a package which deals with data as a data frame for which prep is designed to be used. Also, we import JSON just to be able to deal with the response we are getting back from the API endpoint. So what has changed compared to part 1? Still, we are making use of the OCR endpoint. So https api.einstein.ai/v2/vision/OCR. So whenever you're making use of the Einstein Vision APIs, this will be your basic endpoint from which you start. Now this part is more interesting. Remember last time when we fed an image of some kind of food, we got a label back and a probability, but it would just classify the image as a whole. It would not say where the food in the picture is located, but this time is differently. The text we are trying to detect on the images will come with what is called bounding boxes. And these bounding boxes are literally rectangulars, which we will plot on the image later on. So as you can see, not all these points are being provided. What is being provided, as you can see here, is the minimum x, the minimum y, and the maximum x and the maximum y. So if you would picture a rectangular, you would get the bottom left point of that rectangular and the top right point. Just to help you, with these four coordinates, you're capable of making 4 coordination pairs. So for example, if you want to have the top left point of the rectangular, you would need to combine minimum x with maximum y. And if you would like to have the bottom right point of the rectangular, you would need to have maximum x and minimum y. Now, in this little video, we won't invest much time in plotting the actual boxes, because those who are familiar with plotting polygons and all these sorts of things will know that if we would want to plot these boxes, it would involve some kind of data preparation step in prep, because we would need to create a path variable which would tell Tableau which of the 4 points, or better, in which sequence these 4 points need to be connected with a line in order to reconstruct the actual bounding box. But okay, enough about that. How does it look like? So let me quickly show you the output, and let me quickly look for the receipt we were talking about. Just for your information, this is the receipt where we will be working with in this little video. And in prep, we clearly see that on the one side, it identifies all the standalone numbers, which in this case are the item prices. And on the other hand, it also detects the labels. Again, it comes with a probability. From my first experience is that these text recognitions are very good, so you don't need to care too much about probabilities. Of course, you might want to filter out the very low ones, but as far as I can see here, they all look pretty neat. Then, as I just mentioned when we were looking at the Python script, minimum x, minimum y, maximum x, and maximum y, which respectively are the bottom left point and the top right point of the rectangular. What we will try is see we can define some kind of logic which allows us to sum up only the product item prices. So that, imagine yourself uploading your receipts. As time goes by, you get a nice overall total for all the receipts from, in this case, Walton stores. Still with me? All right. Let's close this little screen and let's run the flow, and let's have a look what we are working with. Okay, so here we are. We just ran the prep flow. So our data has become a published data source. If we right click on the connection, check view data, we do see that all the information now is nicely stored in a published data source. Now I have multiple images, but for the sake of clarity, I will select only the image key of the one we will have a look at here. I appear to know the key, so that's fine. Now, when your text data comes into your table, it's not that structured. Let us put in the information from the receipt. Now, the only thing we do know is that the algorithm scans the image from top to bottom and from left to right. So if you want to reconstruct the order and the structure of the words as they appear on the receipt, we would need to work first taking the maximum of y as a dimension in a discrete way and sort that from high to low. Then secondly, we read from the left to the right. So we would need to take our minimum x, drag it on, put it on discrete and as a dimension, like this. Now let's bring on the labels. I'll put that on text. So if I take an image, let me quickly just put that receipt on my little dashboard. Here we go. And here. Oh, I forgot that I need to sort my max y in a ascending fashion, not descending. Okay, here we go. So the first words on a receipt in this case are Walton stores. And indeed, if I sort from max y ascending and then ascending for min x, I nicely see Walton stores as the first word being scanned. Now, let me focus on a problem that arises when working with these kind of techniques is, for example, olive oil. We see olive oil has the price of £1.78. For the human eye, it appears as if they are on the same line. Why? Let's have a look at olive oil, where it is. The computer says that the max Y position of each character is 392. However, because olive oil and its price are not aligned perfectly, or maybe there is a little tilted angle in our image, they do not appear to be on the same line according to the computer. But do know that you could have a hard time putting them back together, because although it's only one off, you would need to find a logic which recombines these sentences once again. Alright, so far so good. We don't want to bring in the product categories here. What we want to do is find a way how we can isolate the item prices. Now let's have a look how we can do that. So here are just all the labels. Let me put the filter on the data source, otherwise I need to add it every time again. So I'm gonna select my receipt image, which is this one, and there we are. Now what we are interested in are these. Now we don't want to manually select these values for every receipt of Walton stores. No, we want to think of a logic. Now how we can do that is in the following way. If the label contains a number, it will allow it to be converted to a float. If it's being converted by the float function, it won't be null after the conversion. So in this way, we can build a discriminator or a split boolean, let's say, that will allow me to split out these values in a rather easy way. Next, we have all these coordinates. And as I mentioned, we're not going to do the data prep, but we at least can plot a dot where the algorithm has detected an external word. We don't have the image yet here in Tableau, but we will fix that in a bit. What we have done here is we took the minimum y and the minimum x of each word/sentence detected, and we put it on a, it's actually some kind of scatter plot. Then of course, but we're not actually plotting them. As you can see, we get a rough reconstruction of our receipt. Walton stores is on top. On the left, we have the product images. On the right, we have the prices, and then at the bottom, we have a total. Okay, once you have that, we're actually good to go. What we wanted was a graph which shows us the total of all the receipts. And because of the boolean we created, we can now just simply up our item prices, which nicely results in the correct sum of 22 pounds. Secondly, we can also count how many labels we have identified after applying the Boolean filter, and again here it correctly tells us we have bought 11 products. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's great. On top of that, we can create a individual purchased item price distribution graph, which shows us, okay, we bought one product of 0.89, one product of £1.83, etc. It's not ideal. When you want to do a fine-grained analysis, you probably want to come up with a way to also bring in the product labels. But that's not the scope of today. Then last but not least, I brought in the actual images, making use of the URLs from the database. And then I was a little bit sneaky because, as you can see, I used a Tableau sheet with a transparent background on it, which I overlaid to the original receipt. And now we can nicely see where the algorithm detected the words. Of course, this is in the assumption that all the receipts we feed to the Einstein services have the exact dimensions. As I already told you, in reality, in a final app, this would not be a requirement. What you can do is make use of a Python script which trims your images, aligns them horizontally, etc., etc. But for now, I assume that the images I upload have the same size and that I can nicely overlay them. And look at that, we have created a receipt scanner. I can now upload my Walton store receipts, run my prep flow, refresh my dashboard, and it will give me an insight of how much money I have spent in the store. Thank you for watching, and last but not least, there are a million use cases for this. We have seen today that Tableau Prep in combination with the Einstein services open up a huge world of possibilities. Thank you for watching, and I'm looking forward to see you all back in part 3 of this series, where we will dive into object detection and how to actually plot these bounding boxes. Thank you.